All right. Well, this is an impromptu session. Just made myself a cappuccino and decided to go live. And I shall have nobody watching this, I am sure. Unless somebody out there has me tagged. We'll see who you are as you come on in. But I am going to work on some public inputs for the 2029 code cycle. And I'll tell you where I have what I'm thinking, and we can work on some substantiation together if you're watching. If not, then we won't work on substantiation together. You can provide some comments. I heard something come in. Hey, Ryan. Ryan, I am going to, I'm working on some public inputs, buddy. I've got to tweak a couple, which I think I will do that first. And then I have to, and it's on 110.14 terminations. I've got a bunch of changes that I have put in to address the proper selection of a conductor and the overcurrent device. You and I talked briefly about it once before. So I'm going to go to NFPA nfpa.org/70next. And what I'm going to do, so we got somebody else in the house. Who's this? Modern Electric Service. Good afternoon. I've only got a few more to do. I've done probably 150 or so. Ooh, man. Well, you've got more than I do. So I'll tell you what I'm going to fix. I had the chance to speak at NEMA with a few individuals on this 110.14. I'm going to call it the 110.14 issue because we're picking the wrong conductors. Only when the 75° C column doesn't line up with a standard overcurrent device. What people are doing is going to the next larger overcurrent device. And what that does, it puts too small of a conductor on the breaker. So I would need a larger conductor on the breaker to address the amount of conductor that I need, or that the equipment needs, for wicking off heat and to align with how the products are tested. So the first note that I had from my discussion, and I've got to close a couple things. Save. I'm going to save. All right. So the first note I had was let me go to my document. And what I'll do is I'll share my screen. I never know which one I'm pressing. So I'm going to do camera A, monitor right. And that's it. Look at that. And it's really the monitor left. All right. So documents. I go to Eaton, and I go to NEC 2029 public inputs. And I just heard something. Would deleting you know what? So here's my issue with that. 240.4b, I don't have any problem with. In that, so here's the issue. If let's say my 75° C column ampere value is here, and the ampacity is up here, I can't exceed this lower number. But if I change the ampacity of the conductor based on conditions of use, and the ampacity of the conductor is down here below the 75° C column, then I can go to the next larger overcurrent device over the ampacity of the conductor, which puts it below the 75° C column, but above the ampacity of the conductor, which is perfectly fine. Now, The conductor manufacturers would have to say whether or not they agree with that. I don't make a conductor. I just make products that conductors are terminated on, and I know that when what happens is people go to the 75 degree C column and they see, say, 55 amps. Instead of going to the next lower overcurrent device to not exceed 55, they go to the next larger based on the 75 degree C column. And the problem with that is that 240.4b only applies to the conductor ampacity, which 110.14 doesn't change the conductor ampacity at all. So the conductor ampacity is the conductor ampacity, and I can go to the next larger. But I can't do that on the termination. I can't exceed that value that's either in the 75 or the 60 degree, depending upon the equipment. So I had some discussions with some people at NEMA who make equipment and conductors. I had a conductor manufacturer in there. And we did make a change. Oh, is that good? Ryan, this is really good coffee. I have an espresso machine that I grind my own beans and I make an espresso, and I call this a cappuccino, not a cappuccino. It's a cappuccino. So here is what I've got. All right, got to have a good cup of coffee when you're doing this, because otherwise, camera A, monitor right. Boom, baby. All right, so 110.14, I'll show you what I'm doing, and I didn't change this. But I am basically saying that a conductor shall be selected, because I'm getting rid of the word ampacity. I think what confuses everybody is they're using the term ampacity in a term temperature limitations of electrical connections. I don't care about the insulation rating of the conductor. I care about how much copper, aluminum, or copper-clad aluminum lands on that termination, because I need a certain amount of material to pass the heat rise test. So I say a conductor shall be selected and coordinated such that the maximum current permitted for the circuit is determined by the lowest temperature. So I'm saying that you select the conductor so that the maximum current permitted, so what 110.14c is going to get you is the maximum current value. That's all 110.14 does. It doesn't tell you what size overcurrent devices or anything like that, because 110.14c is not supposed to do that. 210, 215, 230 tells you how to select the overcurrent device to protect the conductor and the termination. So all I need to do here is determine that maximum current value that's permitted. And then I have equipment provisions. The determination of termination provisions of equipment shall be based on 110.14 C1A or B. Unless equipment is listed and marked otherwise, the maximum current rating of the equipment termination provisions shall be based on, you know what I should do? So here was the discussion, Ryan. We were talking about this maximum current rating. And really what it is, what if I'd say this? The maximum current permitted instead of rating, I'm going to leave it in there, and maybe we can, if something happens, if they don't like that maximum current rating of the equipment termination provisions, then we can change that language, but I'm leaving it here. And I'm still using 310.16. So the other issue I have is we use table 310.16 for two functions. I am thinking of, and I'm going to put it in my substantiation, I am thinking we should have a table 110.14c that takes 310.16, eliminates the row that talks about the insulation on the conductor, because I don't care what insulation you have on it, other than in here to say that I can't put a 60 degree C conductor in equipment that's rated 75 degrees C or 90 degrees C. I can't put a lower temperature rated conductor insulation less than what the temperature rating is of the equipment. So I'm going to leave that in there. I'm going to leave the reference to 310.16 unless modified by 310.12, and I think that 310.12 should be moved into 215 and 230, but I'm not going to do that this cycle. I'm going to delete those public inputs and get rid of them. I'm going to leave myself open to, I'm going to suggest it in my substantiation that they probably should be moved over, but I don't know that I want to go down that battle right now for this cycle. I'll show you what I'm proposing for that in a little bit. I don't think I have modifications for that. Maximum current permitted for a termination in equipment for circuits rated 100 amps. So we're determining the maximum current that's permitted for the termination in the equipment for circuits rated 100 amps or less, 14 through 1, shall be determined by table 310.16, which we said we're using 310.16, based on one of the following. The current value from the 60 degrees C column. So now I'm being specific. You want that current value, maybe I say the ampere value. I need to move my coffee. This is a very important coffee. It's my afternoon coffee. I'm going to say the ampere value. Hold on. You can't say that you cannot use a conductor insulation lower than the temperature equipment rating. It would prohibit splicing devices. They're rated 105 degrees. Only when you're terminating it on the equipment. If you're splicing, you're not terminating it. So on the equipment, if your equipment is rated 75 degrees C, you can't put a 60 degree C conductor on that equipment. If you want to terminate it outside, fine. But what I'm saying here is that if the temperature rating of the conductor, so the ampere value for the 60 degree C column of table 310.16 for the corresponding conductor size, if the temperature rating of the conductor is equal to or greater than the temperature rating of the equipment. And that actually was in the parent text. I'm moving it down. Where's that at? Where's it at? It's in here somewhere. And I just said we should say it for each. I can find it. And I'll put that in my substantiation. All right, so I'm saying the ampere value from the 60 degree C column. So I'm telling you exactly the ampere value, what value of current that you should be using from that table for the corresponding conductor size if the temperature rating of the conductor is equal to or greater than the temperature rating of the equipment. Then we say the current value from the temperature column of table 310.16. So we said, because I said I'm up above, it was 60 degrees C. Now I'm saying whatever the temperature value is for the corresponding conductor size that corresponds to the listed temperature rating of the equipment, as long as the temperature rating of the conductor is equal to or greater than. So if I have 75 degrees C equipment, I can use 75 degrees C conductor or 90 degrees C conductor, right? Corresponding conductor size that corresponds to the listed temperature rating, as long as the temperature rating of the conductor is equal to or greater than. So if I have 75 degrees C, I can use 90 degrees C, which we do that. We have 90 degrees C conductors, and we landed on terminations for equipment that are 60 or 75 degrees C. Right? So this lets me do based upon any of the conductor ratings. I don't have to, if it's marked that way, if it's permitted by the equipment. And then on the motor side, for motors marked with design letters B, C, or D, and I'm wondering if it's only limited to B, C, or D. The question that came up at NEMA was, why can't there's a new motor out there. So I need to investigate that. the current value from the 75 degrees C temperature column of table 310.16 or higher shall be permitted to be used, period. And that basically is, conductors having insulation rating 75 degrees C shall be permitted to use, provided the ampacity of such conductors does not exceed the 75 degrees C ampacity. It's not an ampacity value. And where we protect that conductor and the termination is going to be elsewhere. So I don't need to talk about protection. And I can have an ampacity that exceeds the 75 degrees C column, because if I increase the conductor size, if I have a conductor and I put a larger conductor on it, the ampacity of that conductor is going to be greater than what's in the 75 degrees C column. So I can't require that the ampacity be less or equal to the 75 degrees C column. It's not an ampacity discussion. It's a maximum current permission for that termination. And then in B is the maximum current permitted for termination in equipment for circuits rated at blah, blah, blah. Maximum current permitted. The current value, and I'm going to say the ampere value from the 75 degree C column. So now I got to go into this, and I got to go to 110.14. Whoop. Oh yeah, I'm at 110.14. There's my 110.14. I'm going to edit my public input. All right, so I'm saying the ampere value from the temperature column, blah, 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 blah. For motors marked design B, C, or D, the current value, the ampere value from the 75 degree C column of table 310.16 or higher shall be permitted to be used. And then B is the maximum current permitted for the termination, blah, 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 blah. The ampere value from the 75 degree C column of table 310.16 of corresponding conductor size equal to the greater temperature rating of the equipment. Conductors with higher temperature ratings. That doesn't make sense, because a conductor does not have a temperature rating. What does the existing code say? What does the existing 110.14 say? 110.14 says, for motors marked conductors having an insulation rating of 75 degrees C or higher, an insulation rating. You know what? I need to use that same language. For motors marked with design letters B, C, or D, conductors having an insulation rating, conductors, for motors marked with design letters B, C, D, conductors, I shouldn't have taken that out. I gotta click on this. Conductors having an insulation rating of 75 degrees C or higher shall be permitted to be used, Control C. For motors marked with design letters B, C, conductors, I can't. Having an insulation rating of conductors having an insulation rating of right or higher shall be permitted to be used. Or higher shall be permitted to be used provided is there a comma in there? Yep, comma, provided the, and it's not the ampacity, comma, provided the ampere value from the 75 degree C column of table 310.16 or higher provided the maximum current permitted for the termination does not exceed the ampere value from the 75/72 column of table 310.16, period. That. I'm glad I caught that. So for motors marked with design letters B, C, or D, and the question is it just B, C, or D? I mean, there was a new motor just introduced last cycle. Conductors having an insulation rating of 75 degrees C or higher shall be permitted to be used. So that tells you it's the insulation rating can't be less than the equipment of 75 degrees C, provided the maximum current permitted for the termination does not exceed the ampere value from the 75 degrees C column of table 310.16. All right, so that, I like that. Okay, all right, and here's your separate connector. We're going to look at that in a second. So I like the motor language now, and here's my issue. The maximum current permitted for a termination in equipment for circuits rated. The ampere value. So I'm saying the maximum current permitted for a termination in equipment. I'm doing good, Drake. Doing good. Can't complain. The maximum current permitted for a termination in equipment for circuits rated blah, blah, blah shall be determined by 316 based on one of the following. The ampere value from the 60 degree C column of table 310.16 for the corresponding conductor size as long as the temperature rating of the conductor is equal to or greater than the temperature rating of the equipment. The ampere value from the temperature column of that corresponds to the listed temperature rating of the equipment as long as the temperature rating of the conductor is equal to or greater than the temperature rating of the equipment. For motors marked with design letters B, C, or D, conductors having an insulation rating of 75 degrees C or higher shall be permitted to be used, provided the maximum current permitted for the termination does not exceed the ampere value from the 75 degrees C column of table 310.16. I'm liking it. The maximum current permitted for a termination in equipment for circuits rated over 100 amps or marked for conductors larger than 1 shall be determined by table 310.16 based on one of the following. The ampere value from the 75 degrees C column of table 310.16 for the corresponding conductor size as long as the temperature rating of the conductor insulation. That's what I'm missing. Temperature rating of the conductor insulation. It's not the conductor, it's the insulation. Insulation is equal to or greater than the temperature rating of the equipment. Conductors with higher insulation temperature ratings provided the maximum current permitted for the termination does not exceed 75 degrees C column for the conductor size used or up to their ampacity if the equipment is listed and identified for use with such conductors, or, I don't like that, for the conductor size used or up to their ampacity. Oh, okay, right. So that's the maximum, or the ampacity could be less Why doesn't it say that up here? Conductors with a higher insulation temperature provided. That's what this one is supposed to be doing. Let's look at what it says. It says conductors with higher temperature ratings. I think that needs to be over here. Conductors with higher temperature. Okay, yeah, so this one here, you don't determine the ampacity. The ampacity of the conductors is not determined based upon the 60 degrees C ampacity of the conductor size used. That's what I'm missing out of this. I have 1, 2, and 3. The value of the 60 degrees C, so that's this one. Conductor is rated 60 degrees C. Review original. Conductors with a higher temperature ratings if the equipment is listed and identified. So one is a conductor that has an insulation rating of 60 degrees C. Do I have that? I don't. So I could say conductors. I'm just going to leave that exactly the same language. Whoop. It needs conductors with an insulation rating. Conductors with an insulation rating of 60 degrees C. (140 degree F). Period. So that's it. So that is if I have a conductor that has an insulation rating of 60 degrees C, 140 degree F, that means I'm using the 60 degrees C column. That's all that conductor is good for. I need to protect it at that. Oh, no, I can't. Because the ampacity of that conductor is now based on the 60 degree C column, and that wouldn't mean I could go. So I've got to get, that's why I didn't do that. I can't do that one. The ampere value from the 60 degree C column of table 310.16 for the corresponding conductor size as long as the temperature rating of the conductor insulation is equal to or greater than the temperature rating of the equipment, period. And if the equipment is 60 degrees C, then it's 60 degrees C, but that's the maximum value is what's in that column. The ampere value from the temperature column of 310.16 that corresponds to the listed temperature rating of the equipment as long as the temperature rating. So let's take a look at that one. So I basically combined this one and this one. Now I can say conductors with a higher temperature rating than 60 degrees C. So I could say the maximum current permitted for a termination. It's not a conductor. It's an ampere value based upon the conductor. So the maximum current determination of the maximum current permitted for a termination in equipment for circuits rated 100 amps or less shall be determined by table 310.16 based on the following. The ampere value for the temperature column from the temperature column of table 310.16 that corresponds to the listed temperature rating of the equipment as long as the temperature rating of the conductor insulation is equal to or greater than the temperature rating of the equipment. And if I look at this, conductors with higher temperature ratings, if the equipment is listed and identified for use with such conductors. So I've combined these two, and then I have this one. Shall be used only for one of the following, or marked 14 gauge, shall be used only for one of the following. The ampere value for the temperature column of 310 that corresponds to the listed temperature rating of the equipment as long as the temperature rating of the conductor. So, and then the third one is for motors, marked with design letters B, C, or D, conductors having an insulation rating of 75 degrees C or higher shall be permitted to be used, provided the maximum current permitted for the termination does not exceed the ampere value from the 75 degrees C column of table 310.16. And then the maximum current permitted for a termination in equipment for circuits rated over 100 amps or marked for conductors larger than 1 gauge shall be determined by table 310.16 based on one of the following. The ampere value from the 75 degrees C column of table 310.16 for the corresponding conductor size, as long as the temperature rating of the conductor insulation is equal to or greater than the temperature rating of the equipment. Conductors with higher insulation temperature ratings, provided the maximum current permitted for the termination does not exceed the 75 degrees C column of table 310.16 for the conductor size used, or up to their ampacity if the equipment is listed and identified for use with such conductors. I like this instead of this. And it would be 60 degrees C up here. No, it's not the same. I'm going to go with what I got. I like that better. Every time I see something I would change, I can logic why I wouldn't do that. All right, so then this one here is separate connector provisions. Separately installed pressure connectors shall be used with conductors at the ampacities. At the ampacities, not exceeding the ampacity at the listed or identified temperature rating of the connector. Wow. And what does it say? Separately installed pressure connectors shall be used with conductors at the ampacities, not exceeding the ampacity at the listed and identified temperature rating of the connector. So what we're saying is, if you have a connector, if I have a connector rated for 75 degrees C, I would look at the size of conductor. Oh crap. Oh. I unplugged the monitor. But it didn't. That's cool. It took it off of there, but it didn't. Okay, so, man, what 2 is saying. Oh boy. What is 2 saying? Huh. Separately installed pressure connectors. So it's saying is if I have a pressure connector that is at the 75 degrees C, that's rated 75 degrees C, I would go to the 75 degrees C column and based upon the conductor size, that will determine the maximum current permitted for the circuit. So it's the weakest link. Oh man, I'm having a hard time with this one. Separately installed pressure connectors. It should say shall be permitted to be used, because I'm permitted to use them as long as, wow, this is really screwed up. Separately installed pressure connectors shall be used with conductors at the ampacity. So if I have a conductor and its ampacity, remember, ampacity is conditions of use. It has nothing to do with the termination. Not exceeding the ampacity at the listed identified temperature rating. There's no ampacity of a temperature rating. And I can have a pressure connector that has a rating less than the ampacity of the conductor as long as I'm protecting it at that value. So all this is supposed to be doing is telling me what the maximum current is when I have a separate connector. It doesn't change the ampacity of the circuit or the conductors. Separately installed pressure connectors, it should be, shall be permitted to be used. Shall, wow, I'm going on a limb. Shall be, oh crap. Gosh, man, it just turned everything off. Shall be permitted to be used. Separate connector provisions. Separately installed pressure connectors shall be permitted to be used where I don't like that. Control Z. I don't like that at all. Separately, so separate connector provisions. So if I have a separate connector, if I'm doing that, a separately installed pressure connector shall be used. Separate connector provisions. Separately installed pressure connectors shall be used if it's a with the conductors at the ampacities not exceeding the ampacity at the listed identified temperature rating of the connector. So all I want to make sure is that I'm reestablishing the maximum current permitted for the circuit. I think what they're trying to equipment markings or listing information may be additionally restricting the size and temperature ratings of connected conductors. Separately installed pressure connectors shall be used with conductors not at the ampacities, not exceeding the ampacity at the listed, not exceeding the ampacities at the listed and identified temperature rating. So that means my separate pressure connector if I have 75 degree C equipment, I have to have a 75 degree C pressure connector. I can't have a 90 degree C pressure connector. I don't know why you wouldn't be able to. Separately installed pressure connectors shall be used with conductors. Oh, this doesn't make sense. How would I fix this? Separately installed pressure connectors shall be used with conductors at the ampacities not exceeding the ampacity at the listed and identified temperature rating of the connector. Why don't we leave this first at the ampacities? Separately installed pressure connectors. The maximum current. What if we started this with the maximum current permitted for separately installed pressure connectors shall be no greater than the ampere value Ryan, gotta go teach class. Good seeing you. By the way, look at the PI to this section submitted by Russ LeBlanc for 2026. He pointed out a similar problem. Might be useful. All right. But yeah, thanks, Ryan. Enjoy your class and good luck with your class. Go break a leg. I will look at Russ LeBlanc's public input. The maximum current permitted for separately installed pressure connectors shall not be greater than the ampere value from the temperature column of table 310.16, which the maximum current permitted for separately installed pressure connectors shall not be greater than the ampere value from the temperature column of 310.16. No. That corresponds to the listed temperature rating of the termination. That corresponds to the listed temperature rating of the separately installed pressure connector. Not exceeding the ampacity at the listed identified temperature rating of the connector. That does not make sense. So the maximum current permitted for separately installed pressure connectors shall not be greater than the ampere value from the temperature column of table 310.16 that corresponds to the listed temperature rating of the separately installed pressure connector. A conductor shall be selected and coordinated such that the maximum current permitted for the circuit is determined by the lowest temperature rating of any connected termination, conductor, or device. Conductors with temperature ratings higher than that specified for termination shall be permitted to be used for ampacity adjustment, correction, or both. So this tells you maximum current is determined by the lowest temperature rating of any connected termination, blah, blah, blah. So what you're saying here is that you're determining the maximum current that's permitted for this separately installed pressure connector, and that it cannot be greater than the ampere value from the temperature column of table 3 10 16 that corresponds to the listed temperature. But if that is not your weakest link, then item 1 could be your weakest link. And the parent text tells you it's the lowest of the two. All right, so I'm good. I think that makes more sense. The maximum current permitted for separately installed. All right, so now, and then informational note, equipment markings or listing information may additionally restrict the sizing and temperature ratings of connected conductors. Equipment markings or listing information may additionally restrict the sizing and temperature ratings of connected conductors. So that's good. All right, so we're going to have to hit next. Let me zoom out. And we hit next. It has changed. All right. Next. Next. All right, so now, okay, so now I got substantiation. So the proposed revisions are intended to improve technical accuracy and better align the NEC text with how equipment is evaluated by the applicable standards, by the applicable product standards, and used in practice. The defined term ampacity applies to a conductor. The NEC defines ampacity as the maximum current a conductor can carry continuously under the conditions of use without exceeding its temperature rating. Section 110.14c is not a rule that changes the ampacity of the conductor, period. I'm going to get rid of itself. Rather, 110.14c is a coordination rule that establishes how the temperature ratings of connected terminations, conductors, and devices are applied so that the maximum current permitted through the connection and associated equipment does not exceed the lowest applicable temperature limitation in the circuit. Use of the word ampacity in this section has caused confusion by suggesting that 110.14c is redefining the conductor's ampacity, when in reality, it is governing the relationship between the equipment termination rating and the conductor selected for that termination. Hold on. There we go. For that termination. Where's that at? I am redefine the conductor's ampacity when in reality is governing between the for that termination. Removing the term ampacity from this section clarifies that distinction and better reflects the actual function of 110.14c, which is to establish a maximum current permitted based on the rating of the termination and the conductor size terminated, period. The parent text of 110.14c is revised to state that the conductor shall be selected and coordinated such that the maximum current permitted for the circuit is determined by the lowest temperature rating of any connected termination, conductor, or device. That wording more accurately describes what the rule is doing. It preserves the existing coordination concept, but avoids implying that the section is recalculating or limiting conductor ampacity as a defined term. The second sentence is retained to make clear that higher temperature rated conductors can still be used for adjustment and correction purposes, provided the applicable termination limitations are respected. I love that. The revisions to 110.14c1 make the same improvement. The existing phrase conductor ampacities used in determining equipment termination provisions is imprecise because equipment termination provisions are not determined by changing conductor ampacity. They are determined by the maximum current permitted at the equipment termination based on the termination temperature rating and the size and material of the conductor connected. The proposed text therefore shifts the focus to the maximum current permitted for the equipment termination provisions using Table 310.16 unless modified by 310.12. This reflects actual equipment application far more clearly. It is the opinion of the submitter that we should not use Table 310.16 for two separate purposes. In the opinion of the submitter, it would be advisable for the committee to create a new table 110.14C that reflects the values of Table 310.16 without the conductor insulation information. This would ultimately ensure each table 110.14C and 310.16 is used for a single function, removing confusion and adding clarity. The submitter did not make this suggested change but leaves the possibility open for the second draft change. So at least now it won't be new material. And I'm going to make this a separate paragraph so that it stands out. This approach aligns with how listed equipment is evaluated and marked. An example of a 75° C termination on a 110 amp circuit breaker illustrates the point. Table 310.16 shows that a 2-gauge copper conductor has a value of 115 amps in the 75° C column. In this application, the table is being used to establish the conductor size that corresponds to the current permitted through the 75° C termination. The fact that the conductor may have insulation with a higher temperature rating does not change the limitation imposed by the equipment termination. The value in Table 310.16, the value of current, the value of amperes in Table 310.16 for the 2-gauge copper conductor in this example, which is 115 amps, cannot be exceeded, and so is paired with a 110 amp circuit breaker. Placing a smaller conductor on this 110 amp circuit breaker would not yield enough conductor mass for the overall test hold on. If the next larger OCPD, a 125 amp circuit breaker, is used, this would place a smaller conductor on the 125 amp circuit breaker causing a condition with not enough conductor mass for the overall tests in UL 489 related to the temperature rise. The conductors own defined ampacity and maximum current permitted through a given per UL 489, and I'm going to bring up the UL 489 document. Open a new tab. If I go to organizations, I'm going to go to organizations and then UL, and then go to 489. I'm going to reference the specific section in 489. Yep, 489. .125 amp breaker is tested with a 1 gauge. And this is table 6.1. Table 6.1. Where am I at? Per UL 489, table 6.1, titled Terminal Current and Conductor Size. Terminal, titled Terminal Current and Conductor Size. A 125 amp circuit breaker, minimum conductor size for a branch circuit, feeder, or similar application is a 1 AWG conductor and not a 2 AWG conductor. Applying a 2 AWG conductor per Article 210 or 215 on a 125 amp circuit breaker would be a misapplication of the circuit breaker / conductor size configuration. Motor applications are not a separate discussion from 210, from Article 210 and 215. The proposed revisions to 110.14c1a and similarly to 110.14c1a improve this clarity by directly stating that the maximum current permitted for a termination is determined from table 310-16 based on the applicable temperature column and the corresponding conductor size. This is clearer than repeatedly referring to conductor ampacity in a context where the actual issue is the current limit associated with the equipment termination. For additional clarity, it could also be proposed to create a table 110.14c and not use table 310c for two different purposes. I'm going to say again, for additional clarity. This proposal, correctly preserves the current role of the conductor insulation temperature rating. The insulation temperature rating of the conductor is still important, but not because it independently establishes a different current limit for this termination. Rather, the conductor used must have a temperature rating not less than the temperature rating of the equipment in which it is terminated. Stating that requirement directly removes another frequent point of misunderstanding. A conductor with insulation rating below the equipment temperature rating is not appropriate for that termination, even if the conductor's size would otherwise appear sufficient. Overall, the proposed changes are editorially and technically justified because they, 1, remove misuse of the defined term, blah, 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 blah. So I'm going to do this. I'm going to say 110.14c2 because we just made that change. C2 is also modified for clarity and accuracy. In 110.14 C2, the NEC is establishing the maximum current permitted for a, what do we call that? A separate connector, separately installed pressure connector. For a separately installed pressure connector. That maximum current is determined by the temperature rating of the termination of the pressure connector and the size of the conductor landed on that termination. That maximum current is determined by the temperature rating of the pressure connector and the size of the conductor landed on that termination. Leveraging table 310.16. The parent text of 110.14c requires that the lowest value determined is the limiting factor. So even if the maximum current as determined in 110.14c is greater than that determined in 110.14c1, C2 is greater than that determined in C1, the lowest value would determine the maximum current permitted for that equipment. Boom. So that addresses the change that we did in C2. This proposal also correctly preserves preserves the separate role of conductor insulation temperature rating. The insulation temperature rating of the conductor is still important, but not because it independently establishes a different current limit for the termination. Rather, the conductor used must have a temperature rating and have an insulation temperature rating not less than the temperature rating of the equipment in which it is terminated. Stating that requirement directly removes another frequent point of misunderstanding. A conductor with insulation rated below the equipment temperature rating is not appropriate for that termination, even if the conductor's size would otherwise appear sufficient. Overall, the proposed changes are editorially and technically justified because they, 1, remove misuse of the defined term ampacity in a context focused on equipment termination limitations. 2, clarify that 110.14 Charlie establishes the maximum current permitted through the termination circuit relationship, not the intrinsic ampacity of the conductor. 3. Better align NEC wording with listed equipment application and product standards. And 4. Reduce misapplication in conductor and OCPD selection by separating conductor ampacity concepts from the equipment termination temperature limit concepts, period. That makes sense. All right, so then we're going to do next. Next. All right, submit. All right, so now that that is updated and cleaned up, I'm going to view it. I am going to save it. Mark it with a T. I'm going to go to downloads. And it's right there. And my value is 110.14c 1310. 110.14c 1310. 110.14 Charlie PI 1310. I'm going to do a Control C and come over here and go to Public Inputs Submitted, Terminations, V, and I'm going to hit Replace. Boom. So I updated that one. The next one is in 210.19. So let's go to 210. 210.19. 210.19. I'm going to edit. Oh, that's 210.20. Close. 210.19. Edit. All right. The minimum branch circuit conductor size shall be in accordance with 100 such that the maximum current, the maximum current determined by 110.14c is not less than the continuous loads plus 125% of the non-continuous loads plus 125% of the continuous loads. So what we're saying in 210.19a1 is that the minimum branch circuit conductor size has to be in accordance with 110.14 such that the maximum current determined by 110.14c is not less than the non-continuous loads plus 125%. So is not less. Okay, so that just means that what that means is that's taking into consideration of that 75° C column. That has to handle the continuous current. And then the minimum, and the second one is the ampacity adjustment or correction factors. That has nothing to do with the termination. And then B, I don't have to worry about any of this. So I hit next. And that was the change that we made in the discussions. But I got rid of the rating value, of the rating information. Now 110.14c is just determining a maximum value. That's all it is. All right. So I cleaned that up. I hit next. Hit next. Okay, now let's look at my substantiation. This section includes two different calculations. One determines the impact of the conductor and the other determines simply the size of the conductor. One takes into consideration the conditions of use and the other only the termination provisions based upon 80% rated equipment. The parent, one takes into consideration the conditions of use for the conductor ampacity, and the other only the termination provisions based upon 80% rated equipment and not the conditions of use for the conductor ampacity. The parent text recognizes that it could be that the capacity the ampacity is not less than the larger of the two calculations, or simply the size of the conductor is not less than the larger of the two. The rewording of this section addresses the use of the term ampacity, which should not be in A1 because the determination here is solely based upon 125% of the continuous plus the non-continuous loads and not the conductor conditions of use. Ampacity is a defined term. It is not appropriate for this term to be used in this section. The exceptions now exist at the end of the section A, but both apply to only one, which is the same as that which is found in 215 for feeders. And I'm going to say one, which is A1. Okay. So I'm go with that. Go with that. Next, next, next. Boom. Submit. And I'm going to hit view. This is 210.19, 1312. 210.19, 1312. 210.19, 1312. 210.19, PI 1312. There we go. Control C. Come over here into a V. And I'm going to replace. Okay, now I got to do 210.20. Hit close. Come down to 210.20. And what I'm doing is I'm removing this rating. Have a rating or setting compliant. So I say the rating or setting of the OCPD shall not exceed that specified in the applicable articles for equipment and in accordance with 110.14c shall not exceed the maximum current permitted for the termination associated with the size wire terminated. So I removed the rating terminology and just said so it says, see, the applicable articles for equipment and in accordance with 110.14 shall not exceed the maximum current permitted as determined by 110.14c for the termination associated with the size wire terminated. So that takes care of the 110.14c and gets rid of the termination value reference. So I do OK, and I do next, next. This change ensures the alignment of 110.14c and the maximum current permitted through the termination when a specified conductor size is landed on the equipment. This requirement is much like that which is found in the same section, establishing the minimum size OCPD based on 125% of the continuous loads plus the non-continuous loads. This added language establishes the maximum size OCPD to ensure the termination, ensure the maximum current permitted for the termination as determined in 110.14c is not exceeded. This aligns with how circuit breakers are and related equipment are listed and tested. Bam. Changes were also made to make the load plural, as continuous and non-continuous applies to loads. The word load, plural, as continuous and non-continuous applies to loads and not just a single load. Awesome. Hey, Juan. Doing good. Doing good, Juan. Glad you were able to tune in. All right, so I hit next. I hit next. I hit next. I do that. I hit submit. Now I have submitted and I've changed my public input. I go to view, and this is 210.20.13.13. I'm going to save this. 210.20.13.13. 210.20.13.13. Downloads. 210.20 PI 1313. Do a Control C. Control V. I'm going to hit replace. All right. 215.4. Let's go fix 215.4. 215. Edit. All right, so the minimum branch circuit in accordance with 110.14 shall the maximum, okay, such that the maximum current permitted as determined by 110.14c is not less than the non-continuous loads, blah, 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 blah. The minimum feeder conductor size shall have an ampacity. Okay, so the first one is just determination, so there should be no reference to ampacity. The second one is about ampacity, and then there's 1, 2, 3 exceptions. Exception number 1 to 1, if the assembly, blah, blah. Exception number 2 to 1. Ground conductor, this should be exception number 3 to 1, where a portion of a feeder is connected at both its supply, blah, 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 blah. There's an informational note. All right. The feeder conductor ampacity shall not be less than that of the service conductors where the feeder conductors carry the total. All right. I hit next. I hit OK. I hit next. Next. Modifications align the structure of 215 with Article 210. Addresses this is 1318, so this is on this addresses the use of the term ampacity. Okay, so what I'm going to do, here's what I'm going to do. I'm going to go back to 210.19. I'm going to look at my, okay, I'm going to grab the language from my substantiation in 210. This section includes 2 different calculations. So first, okay. All right, so I'm going to get rid of this. Very similar to 210.19. This section is very similar to 210.19 and includes 2 different calculations. One calculation determines the impact of the conductor and the I will have to call him back. You know what? I'm going to do that now. So I'm going to put you on pause.
Hey everybody. If you're watching this, that means I am either having some technical difficulties or had to step away to do something simple like sign for a package. I don't know. I'd like to remind you to take this time to go out to thomasdimitrovic.com or, to make it easy, www.tdunplugged.com. Take a look at what I have to offer on my website. I'm doing a blog. I've got some information up there for you. I will be putting out info on things like my Q&A Friday and Tech Tuesdays and things like that. Anything that I'm doing online and some industry information. So please don't forget, check out my website. Also, don't forget to check out www.youtube.com/TD Unplugged. It's all right here. Don't forget, check those out. Enjoy the technical information, and leave a note on pretty much all of the pages on my website. Also, all of the videos. You can leave notes, comments. I will be checking those, and we will hopefully follow up on those during our Q&A Friday sessions. Thank you for what you do for the industry. Thanks for what you do for electrical safety. Remember to stay safe. Please always stay tuned in to my channel. So sit back, relax. If I'm not back already, I will be back shortly. Thanks.
All right, I'm back. Sorry about that. Okay. Um, all right, so let's go back to Terra, and I'm looking at the substantiation. There it is. All right. All right, so this section is very similar to 210.18. Okay. 210.18 and includes two different calculations. One calculation determines the impact of the conductor and the conductor size, the conductor ampacity, and the other determines simply the size of the conductor based on conditions of use, and the other determines simply the size of the conductor based on termination provisions. Boy, I gotta go back and fix the other. All right, so one takes into consideration the conditions of use for the conductor ampacity, and the other only the termination provisions based upon 80% rated equipment, and not the conditions of use for conductor ampacity. The parent text recognizes that it could be that the ampacity is not less than the larger of the two calculations, or simply the size of the conductor is not less than the larger of the two. The rewording of this section addresses the use of the term ampacity, which should not be in A1 because the determination here is solely based upon 125% of the continuous plus the non-continuous loads and not the conductor conditions of use. Ampacity is a defined term. It is not appropriate for this term to be used in this section. The exceptions now exist at the end of section A, but both apply, but they apply to only turn off the basement lights. Continuous loads are not the and pass only A1, which is the same as that which is found in 210. 210 for branch circuits. All right. So now I go and I'm going to hit next, 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 and I do this, submit. All right, so now I do a view and I do save as Word. So this is 215.4 PI 1318. 215.4 PI 1318. I go to downloads, 215.4 PI 1318. Okay, I do a Control C, and then I do a replace. Boom. All right, so we did 215.4. Now we got to go to 215.5. Let's close that. And we go to 215.4, now 215.5. And remember, what we're doing is we're getting rid of that word rated. Okay, 215.5, continuous, non-continuous. The rating of the OCPT protecting a feeder shall not be less than the continuous. So that's the bottom. And then the rating or setting of the overcurrent protected device shall not exceed the maximum current permitted for the equipment, as determined by 110.14c. So that's perfect. I'm not using the word rating, so I don't have to change a thing there. All right, so I realigned 215.5. So the substantiation is going to, the changes in this section align the structure in the same format as that found in Article 210 for consistency. A new first level subdivision C for equipment ensures that the rating or setting of the overcurrent protective device does not exceed the maximum current as determined by the termination requirements in 110.14 Charlie. I must have been speaking this, and it did the voice translations. All right, so so that's all I'm going to say is that it aligns with the. So what we did was we restructured this section to match what's found in 210, and then we have a new first level subdivision C for equipment, and that ensures that the rating or setting of the overcurrent protected device doesn't exceed the maximum current as determined by the termination requirements in 110.14c. All right, so that's simple. Keep it simple, stupid. All right, next, and I hit this, and I hit submit. So now we updated that one. I do a view, and I save as Word, and then I do, this is 215.5 PI 1319. 215.5 PI 1319. 215.5, 215.5 PI 1319. Control C, and then I come over to terminations, do a boom, 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 V. I do a replace. All right, so that's 215. Now, 230.42. I'll tell you what I'm going to do. I'm going to delete this one. And I'll tell you why. I was speaking with 230.40. Number of service entrants. 230.42. 42. All right, 230.42. Yeah. I'm going to do this. I'm going to delete this one. I am going to delete. What's this one? The minimum service entrance conductor size shall be in accordance with 110.14 and have a, oh yeah, I gotta fix that. All right, so I'm gonna delete this one. And what this one is, I'll tell you what I was doing here. This one, I was relocating what's in 310.12. In 310.12, we have a provision to, to permit a smaller conductor. I'm not going to propose removing that and moving it. I'm going to suggest it in my substantiation for 310.12 because I have another modification over there. I'm going to suggest that it probably should be relocated here. That will open the door for second draft. So I'm going to delete this one. I'm going to delete. Okay. That's another nice thing about doing the public inputs is you can make a public input. If you decide not to do it, you can go back and delete it. So it's not a big deal. Now I'm going to edit this one because this has that word maximum rating. So service entrance conductor shall have an ampacity not less than the maximum calculated load to be served. Conductors shall have an ampacity or size not less than the larger conductor of A1 or A2. Ampacity size shall be determined in accordance with 310.14 and comply with one. The maximum current of busway shall be, okay, so all that's good. The minimum service entrance conductor size shall be in accordance with 110.14 and have a maximum current value not less as determined by 110.14c, not less than the sum of the non-continuous loads plus 125% of the continuous loads. There are two exceptions to that. The ampacity, the minimum service entrance conductor size shall have an ampacity not less than the maximum load to be served after the application. So that's a proper use of the word ampacity. I'm getting rid of it from A1. And then you have B, specific installations, and then C is grounded conductor. So I hit next. That should show me my shall be have an ampacity or size. Ampacity and size shall be determined. So we're doing two things. One is you're determining the size regardless of the insulation. So you're using the temperature rating column of 310.16, and that's going to be based on 110.14 and all that jazz. So, all right, I'm going to hit next. Next. Okay, align with similar requirements. All right, so what I'm going to do is I'm going to come back over to this previous language, and I'm going to copy this substantiation. This section includes two different calculations. This section includes two different calculations. One determines the impact of the conductor ampacity, and the other determines simply the size of the conductor. One takes into consideration the conditions of use for the conductor ampacity, and the other only the termination provisions based upon 80% rated. Thank you for streaming this. Love this type of information. Sure thing, Josh. I don't like, sometimes it's just like, I've got to do it anyway, and you never know. People might learn something or teach me something in the process. So this section includes two different calculations. One determines the impact of the conductor ampacity, and the other determines simply the size of the conductor. One takes into consideration the conditions of use for the conductor ampacity, and the other only the termination provisions based upon 80% rated equipment and not the conditions of use for the conductor ampacity. The parent text recognizes that it could be that the ampacity is not less than the larger of the two calculations, or simply the size of the conductor is not less than the larger of the two. The rewording of this section addresses the use of the term ampacity, which should not be in A1 because the termination here is solely based upon 125% of the continuous loads plus the non-continuous loads and not the conductor conditions of use. Ampacity is a defined term. It is not appropriate for this term to be used in this section. The exceptions now exist. I didn't do that with this, so I'm going to get rid of that. All right, so let's do a next. All right, so let's do a next, next, signature, submit. All right, so let's go to view. All right, so here's what I did. Conductors, conductors shall have an ampacity or size not less than the larger conductor of 230.42A1 or A2. Ampacity and size shall be determined in accordance with 310.14 and comply with 110.14C. The maximum current of busway shall be that value for which the busways have been listed or labeled. All right. Instead of where the service entrance conductors supply continuous loads, I just said in A1, the minimum service entrance conductor size shall be in accordance with 110.14 and have a maximum current value not have a maximum current value. I got to fix that. It shall be greater than the minimum service entrance conductor size. Oh, the minimum shall be in accordance with 110.14 and have a maximum current value as determined by not maximum current value. I got to fix that. Edit. The minimum service entrance conductor size shall be in accordance with 110.14 and have a maximum and shall not a maximum current value. It's not a maximum. Oh. So that is right. A maximum current value as determined by 110.14c. That is not less than the sum of the non-continuous loads plus 125% of the continuous loads. So you take the value of one that's determined in 110.14c shall have a current value as determined by 110.14c that is not less than the sum of the non-continuous loads plus 125% of the continuous loads. So you go to 110.14c and that value can't be less than the non-continuous plus 125%. And the value in 110.14c is based upon the temperature column of 310.16. Gosh. You go to the temperature column and then you go to the size of the conductor, and that's the maximum value. So you determine that current value, and it can't be less than the sum of the non-continuous loads plus 125% of the continuous loads. I like taking that word maximum out of there. And there should be a C. And have a current value as determined by 110.14c that is not less than the sum of the continuous blah, 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 blah. All right. So that's good. All right. So that cleans that up. I even get next, and I should go back. This is the challenge with this, is because now I fixed this. I got to make sure I don't want to use that word maximum in the others. I already did this. So next, next, next. Checkbox. Submit. I'm going to download this. View. Download. Save as Word. All right. So that is PI. So it's 230.42, PI 1325. 230.42. 230.42 PI 1325. Is that what it is? 230.42 PI 1325. All right. Control C. I come over here to terminations. Control V. 230.42. Why is that? 230.42. Right? This one I have is 230.41. Yeah, okay. That was incorrect, so I gotta delete this one. Move to trash. All right. All right, so 230.42. Let's go back. Let's go take a look at 215.4. I just want to make sure that I don't have that word maximum in there. 215.4. If I go to edit, the minimum feeder conductor size shall have an ampacity not less than the maximum load to be served. Well, that's the ampacity. 1. The minimum branch circuit conductor size shall be in accordance with 110.14 such that the maximum current permitted, I'm just going to take out this, such that the current determined by 110.14c, the ampere value determined by 110.14c is not less than the non-continuous loads. So that takes out the maximum value. I got to go back. I got to do this. What did I say? The ampere value determined by. Next. The ampere value determined by. I'm going to fix the other spot in here. The ampere value determined by. Edit. Nope, that's good. Close. Got to go to 210. The ampere value determined by. All right, so then we go back. Boy. Nope. Edit. Okay, the minimum branch circuit conductor size shall be such that the ampere value determined by 110.14c is not less. That's perfect. All right. Next, 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 next. Submit. All right, I'm not going to go back and save that, download that. That's 250. This is 210. All right, I should be good here. All right, so I fixed 210. I fixed 215. I was doing 230 when I fixed that. So what are the other two? 240.4b and C. 240. 240.4b and C. And we're going to go to 310.12 after this one. 240.4b. All right, so if I hit edit, what is this? The next higher. Ooh, edit. The next higher standard over current protected device rating above the ampacity conductors shall be permitted to be used, provided all the following conditions are met. The conductors being protected. What did I change? The next higher standard rating selected does not exceed the termination current. The next higher standard rating selected does not exceed the maximum current value, maximum current value determined by 110.14c. That was when I was at NEMA last week. That was the rating, was the language it was suggested to me to change, and I am doing that. So I hit next. All right, this probably ensures that the conductor size and the equipment within which it is terminated are properly aligned. The requirements of 110.14c establish the maximum current permitted to flow through the termination based on the temperature rating of the equipment. This language ensures that the OCPD provides the protection required based on the limitations as set forth by. All right, I like it. Next, next, next. And I do that. I hit submit. All right, so I'm good with this one. I'm going to hit view, save as Word. This is 240.4b 1323. 240.4b 1323. 240.4b 1323. Do a Control C. Come over here. Control V, and I'm going to PI. Oh. Okay, I'm going to send this one to trash. Move to trash, and this is going to be 1323. All right, 240.4c. Let's close. Let's go to C, edit. Where the OCPD is rated over 800 amps, the ampacity of the conductors it protects shall be equal to or greater than the rating of the OCPD defined. Oh, I don't need this. Because, okay, so I was going to say that you can't exceed, but when it's over 800 amps, I can't go to the next larger. So I can just delete this public input. Done. 240.4c, I don't need to address when they go to the next larger. So I'm going to delete this one. I'm going to do a Control C. And I actually have a folder for deleted B. All right. In fact, 310. These two. All right. So here's what I'm doing in 310. So I've addressed all of the termination stuff. Now 310, I was going to delete 310.12 and move the contents to 215 and 230. Based on some discussions with some Panel 6 experts, they recommended against that for this cycle. And I don't really, it's not a hill for me to die on. I don't need the headache. So I'm going to keep this one and I'm going to delete the second one. Let me just make sure I got the right one. So this is 1308. 1308 was going to delete it. I'm going to delete that. 1308. Delete. Okay. And then I'm going to go over here to 1308 and I'm going to move this puppy into the deleted folder. Get rid of that one. That was the other thing I got. I deleted the public inputs in 215. I got to go to my garbage. I got to go to my junk. There it is, 230.41. How do I want to move this. How do I move this to deleted? Can I just drag it? I'm going to move this down to deleted. I want to move this down to here. It did. It did. 240.4b. I think I deleted this one too, didn't I? 240.4b. No. No, that was fine. All right. So that's good. All right. This I deleted 230.41. 240.4b. That's here. 230.41 pi. I think this was the language. Conductors minimum. Oh, no. Don't save. I did. I want to delete that. That's gone. All right. 210. 310.12. All right. So let's go back. All right. So this one here, I'm keeping. And what I'm doing is I'm adding language that the service equipment shall be listed and marked as having been approved for the application of the conductors identified in table 310.12a. So that just is in accordance with the product standard. And I think in the panel state or the substantiation, I referenced that. UL 67 requires, so that's good. All right, so all I'm doing here is just saying that it needs to be listed, submit. All right, so nothing changed. I'm golden with that one. I just deleted the removal. And I believe I deleted in 215. I deleted the public inputs for .18. Oh yeah, I gotta delete this one. So 215.18. This is where I was moving it. So I'm gonna hit delete. Okay. 215.18 is no longer a public input. I gotta go back to my thing here and go to 215.18 and put this into my deleted. Oh, and what I need to do, okay, so let me go back over to 310. So remember, I wanted to leave the door open so that if I wanted to in the second draft, if I wanted to move things, I can do that. So I'm going to go to edit, and I'm going to go to next, next, next. And I am going to zoom in. Okay, so all right, this public input adds the requirement that the equipment be listed for the application as per the table in this section. These conductors are one size smaller than that which a circuit breaker or other surface equipment and feeder equipment is listed. UL 67 requires, UL 67 requires that these panel boards be tested for this purpose as part of table 11.1 of UL 67. This table identifies these conductor sizes and includes a note to the table that states the following. Note C includes a note C to this table that states the following. The values in parentheses are capable of being used in the main terminals from a three-phase panel board intended for use, single-phase three-wire panel board intended for use as residential service equipment when the panel board is marked in accordance with 34. Blah, 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 blah. This change, this public input, this public input aligns the requirement with the UL standard for the product, period. In addition, this submitter feels that it is the opinion of this submitter that the requirements here could be better located in Article 230 for service equipment and Article 215 for feeder equipment. The requirements. So here's my logic. If I go to 310.12, is saying for one family, the individual dwelling units of family and multifamily dwellings services. I'm just going to close this over here. Don't save. For one family dwellings and individual dwelling, service and feeder conductors supplied by a single phase shall be permitted to be sized in accordance. So this talks about sizing a feeder and sizing service conductors. And that's what we do in 215 and 230 respectively. So my issue is, and I just deleted the public inputs that did this because I'm putting in language in my substantiation to leave the door open in the public comment phase that if I want to do that, I can do that and it not be new material. But my suggestion here is that A, for services rated 100 amps to 400 amps, the service conductor supplying the entire associated with dwelling and service conductor supply the entire load shall be permitted to have an ampacity not less than 83% of the service rating. Well, if I go to 230, if I go to chapter 2, 230, services, and I'm going to go to the service entrance conductors, minimum size and ampacity. So we determine the minimum size and ampacity here in 230.42. And if I look at 310, it says, shall be permitted to have an ampacity not less than 83% of the service rating. So, so I'm doing an ampacity calculation for service equipment over in 230. This technically should be in 230, not here in 215. And Table 310.12a deals with services and feeders, but A is just services. So there's a lot of issues with this, and I'm going to put that in my substantiation. The requirements of 310.12a should be located in Article 230. In addition, the table 310.12a addresses both feeders and services, but is in A, which is only applicable to feeders. So this section has challenges with regard to scope and style manual. This public input is merely addressing the alignment with the product standard, but an argument can be made that it must be changed and consideration should be given to move these requirements elsewhere in the NEC. 310.12a should move to Article 230. And 310.12b, 310.12b, which is, wait a second. Oh, wait. A is services, B is feeders. B, C, and D, B and C, B and C, B and C should move to 310.b, and 310.12c should move to Article 215 for feeders, and 310.12d should be located in Article 215. In Article 2, what? Where would you put the grounded conductors? That would be 2. Grounded conductors, should that be 250? No, 200. Article 200. Article 200. Article 200. I'm going to hit save. Next, next, next. That at least opens the door for the public comment phase. And I think I made a public comment. Let me hit view, download. This is 310.12, 1306. 310.12, 1306. 310.12, 1306. 310.12, PI 1306. Control C. And 310.12. Move to trash. All right, so that's 310.12, PI 1306. I thought I did a 200, or did I do 250? Man. Close. Let's go to 200. Nope. Let me go to 250. Running and bonding. Nope. I didn't put it there either. All right, so I think I put it into 230. Let's say. Was it one of my deleted? 230. Is it 230.69? Yeah, there it is. 230.69. I think I deleted this one. I've got to make sure I did. 230.69. 230.69. No, I didn't. So this is the services rated 100 amps to 400 amps. Right, so I'm going to delete this one and hit delete. That's PI 1304. So I got to go over here to PI 1304. Don't save. And move this down to my deleted. So apparently I did not address D. Grounded conductors shall be permitted to be sized smaller than the ungrounded conductors if the requirements of, okay, for feeder conductors are met. So I did not, and I would argue that probably should be located in 200 for grounded conductors. Use and identification of grounded conductors. So you would expect that if I can do something different with that grounded conductors and service applications, I would either find it in 200 or in 230. One of the two. So, but in any case, that sounds good. All right. I think that's good enough. All right, so I don't know how many people we got out there, but thanks for joining in. Hopefully we got something out of making some public inputs around this. I still have to look at Article 230. I want to put some public inputs in for requiring IR windows or continuous thermal monitoring for service entrance equipment, and also in 215 for feeder supplied equipment on the secondary of a transformer. So those are two areas that I want to focus on next. And what I'll do is I'll probably try to go live whenever I do that. So Josh, Juan, Ryan, I know Ryan's teaching a class right now. Hopefully we can make it happen before the 9th. A lot of work to do before the 9th. All right, everybody. Take care, stay safe, and stay healthy. Catch you maybe tomorrow, sometime this week. See ya.